So I want you to take your foldable and pretend like you're folding it in half, but not actually fold it in half. Match up the corners, but then only crease the top and crease the bottom, because that tells us where the middle is. And then we make barn doors, folding to the crease and folding to the crease. Okay? Does everybody understand that? Guys, why are we making this foldable today? So the last couple days, even the last time we did a foldable I gave you, this is what? So much, right? And if we can make barn doors, we can open just a little bit at a time, right? Now, I need you to take your scissors. I'm going to take this barn door and open it just enough so I can see where it says complex numbers are written. And I want to cut right above where it says complex numbers are written. So, I don't know if you normally cut barn doors in half. I don't have a barn, so I don't know. But cut that one in half, but only to the fold. See how it's cut only to the fold? Okay. And then do the same thing on the other side, cutting right above, dividing complex numbers. Yes, I know you normally don't cut barn doors in half. I was just teasing. Stop freaking out. So now I can really only open a little bit at a time. Does that make sense? Okay. Are you ready to begin? Okay. So let's begin with this top one. Imaginary numbers is the title on the door. Open this door. I'm going to zoom in so you can see a little clearer. Okay. Yesterday, we wrote 2 real solutions and 1 real solution and no real solutions, right? And I asked if that implied something, and you were like, yeah, fake ones, ha ha ha, and we laughed about that, right? Okay? And then what did I say after that? Foreshadowing, right? Foreshadowing, okay? Because it's not fake answers, they're imaginary answers. So today I want to define that for you, and I want to be able to use it in several different ways. Okay? So the first thing I want us to write is the definition of imaginary numbers. Okay? The imaginary unit is, I is defined as I equals the square root of -1. Because that's what caused us to have not real answers, right? When we went to take a square root and there was a negative inside. Because when you actually press it in your calculator, it says non-real, doesn't it? Okay? Well, if your calculator's in the right mode, it does. We can actually put it in a mode where it doesn't. Okay? But we're smarter than calculator. We don't need that. Okay? Now, please notice how I drew the I. I drew like a little tail on it, right? Because if it's typed, it's actually in italics. But I am not a computer. And so I can't write in italics. So I just write it kind of like in cursive. Okay? All right, so examples. Last week you did a lot of practice on simplifying radicals, right? And I said it's for a future date. It's today. Okay? How can I simplify this? I can simplify it as -1 times 4. Well, what's the square root of -1? What did I just tell you? I. And what's the square root of 4? 2. How could I simplify this one? -1 times what? 9 and 5, right? Why would I choose 9 and 5? Yeah, we know the square root of 9, don't we? Okay, so what's the square root of -1? I. What's the square root of 9? 3. And what's the square root of 5? I don't know either. I'll leave it alone. Okay? Now here's the deal. Yesterday I made a really big deal about the fact where if we take the square root of 4, we get what? +2, right? Why didn't I do that today? Who put the root sign in the problem? It was already there. Them, right? They did. When do we have to worry about putting the plus or minus? When we put the square root sign in the problem, right? Okay. All right. So right here, though, we have a little bit of space. You can't see where the bottom of my page is, but it's right here. So I have a little bit of space right here. What does that mean? Yeah, it's Spanish, right? It's in Spanish. It means caution. It does not mean congratulations, which is what they thought last period. Okay? And it also does not mean 100. Okay? I don't even know what that word is. Okay, but it's not this one, right? Okay. Here's what I want to caution you about. Negative square root of 2 does not equal I square root of 2. Where does the negative have to be for me to get an I? Inside. That's exactly right. Okay? Negative square root of 2 actually just equals negative square root of 2. The only way we can get an I out is if the negative is inside the root sign. Does that make sense? Okay? Now, there's this circle. This was pretty fun to make. And by fun, I mean the opposite of that. I had to pull on all of my Google Level 1 and Google Level 2 training. No, I'm just teasing. It was just annoying. Okay. Here's what this means. Okay. I equals I. Do you agree with that? I equals I. Okay. How do I get to I squared if I start with I? I times I, right? Right? That equals I squared. Well, what does I actually equal again? The square root of negative 1. So what is the square root of negative 1 times the square root of negative 1? If I'm squaring something that's being square rooted, what do I end up with? Just the thing that was inside, right? So I squared actually equals negative 1. Okay? Well, how do I get from I squared to I cubed? I squared times I, right? That gives me I cubed. Well, what did we just decide I squared equaled? Negative 1. What's negative 1 times I? Negative I, right? Or negative 1I. Yeah, absolutely. Okay? So I cubed actually equals negative I. Okay? How do I get to I to the 4th? I to the 3rd times I. That's I to the 4th, right? Well, what did we just decide I to the 3rd equaled? Negative I. What's negative I times I? Negative I squared. And what did we decide I squared equaled? So negative 1? Positive 1. I to the 4th actually equals positive 1. Now, do you want to see why it's in a circle? Are you curious about that? How do I get from I to the 4th to I to the 5th? I multiply I to the 4th times I, right? That's I to the 5th. What did we decide I to the 4th equaled? 1. And what's 1 times I? I. And how do we get from I to the 5th to I to the 6th? I multiply by I, right? That's I to the 6th. And what did we decide I to the 5th was? I. What's I times I? I squared. And what does I squared equal? Negative 1. Guess what I to the 7th is going to equal? And I to the 8th? And I to the 9th? And 10th? And 11th? You see why I put it as a circle? Pretty cool, huh? Any questions so far? We good? Okay, let's close that door. But before we go on, let's write something on the front of this door that we just weren't ready to write a second ago. Okay? Let's write what we know I equals. What does I equal? The square root of negative 1. And what does I squared equal? Negative 1. Got it? So let's go down to the next door. Complex numbers, graphing complex numbers. Okay? Now, I'm always afraid when we get to this lesson. Okay? Not because I don't know how to do it, because I know how to do it. I'm good at it. Okay? What I'm afraid of is that you're going to see this word and shut down because you skipped rule number 1. Why would people freak out when they see this word? It's hard, right? Complex means hard. But guys, is that all complex means? No? Can I prove that to you? Okay. Let's open this door. Here's what I want you to know. Complex numbers are written in this form. A plus B I. A is the real part. BI is the imaginary part. That's what I mean by complex here. I mean 2 different kinds of things together. It's complex. There's a real part, there's an imaginary part. Got it? Now we can graph complex numbers on the complex plane. Again, just because it says complex doesn't mean it's hard, does it? Okay? The real axis goes left and right, just like the axis that you're used to being here, which is what? X-axis. The imaginary axis goes up and down, just like you're used to what axis? The y-axis. So if I'm plotting the point 2 plus 3i, I go over 2 on the real axis, because that's the real part, and then I go up 3, so 3i on the imaginary part. How would I plot the number 3 on the complex plane? So just go over 3 and put a dot. How would I plot 2i? Up 2i and put a point. How would I plot 2 minus 2i? Right 2, down 2. Put a point. And how would I plot negative 1 minus 3i? Over 1 left and then down 3, correct? Good job. Any questions on graphing complex numbers? Okay. Go ahead and close that door. Open this door up here. Okay. Now, before I open it, we're going to talk real fast. Okay. This door right here, this is our focus today. Adding, subtracting, and multiplying, this is our teak for the day. Okay? This is our focus. Well, I had to teach you this so you know how to do that. I showed you this because it's too easy not to. Okay? That's not required for me to teach you, but again, that was too easy not to show you, right? And do I sometimes teach you stuff that's not in the teaks? Yes, because I think it's important. Okay? So here's our focus for today. Are you ready for focus? Okay. Adding and subtracting is where we're going to start. Adding and subtracting. We add real plus a real and imaginary plus imaginary. Are you allowed to add real and imaginary? When is the only time ever that adding real and imaginary worked? Space Jam. That's the only time. Space Jam is the only time. Okay? Otherwise, okay. Maybe Who Framed Roger Rabbit? Maybe. Okay? Probably yes. I'd say probably yes. But just only those 2 times. Well, there was that music video. You remember that music video? It's like the very first music video ever on MTV. I don't even remember what the name of it is now. Please don't be mad at me. I mean, you can be mad if you want. I don't care. You never watched MTV? Okay, sorry. It used to be cool. Okay? I'll see if I can search up the name in just a second after we're done. Okay? Real plus real, imaginary plus imaginary. 2 plus 3. Okay, that took entirely too long. You're scaring me a little bit. 2 plus 3 is 5. Okay. 5i minus 2i. Okay, that was much better. Excellent. And that's it. 4 minus 2. Excellent. Negative 3i minus negative 5i. I heard too many of the wrong answers. Can you try again? Negative 3i minus a negative 5i. Let me write that down so we can see it. Minus a negative 5i. Yeah. So 2i. We good with that? Do I need to do any more adding and subtracting examples? You got it? Okay. Some of you are looking like I'm an idiot. I'm used to that, but I'm just trying to make sure that we're good, okay? What about multiplication? What about negative 10i times 2i? Negative 20, what? I squared, right? I times I. Okay, so let's have a quick discussion. Just a quick commercial break, okay? Is I a variable? No, it's not. We're never going to, quote-unquote, solve for I, are we? I is just telling us this is the imaginary part. Okay? Does sometimes I act like a variable? Yes, we just decided that, right? I times I is I squared. Sometimes I acts like a variable. So sometimes we can treat it like a variable. Yes, ma'am? Oh, yeah, absolutely, yeah. We're not done, are we? Okay? Because we know that I squared is negative 1, right? We even wrote it up here to help us out. So I squared, this part right here, this is negative 1. Well, what's negative 20 times negative 1? 20. Now we're done. It even tells us right here, it's not simplified if I has an exponent. That's kind of why we did the circle thing, so you would realize what happens when we have exponents, right? Okay. Now comes another, I didn't ever say back to the show. Sorry, we were back to the show. But now we have to take another commercial break. Okay? Because we talked about the fact that we can't add real and imaginary, right? Can we multiply them? What's 2 plus 3x? It's just 2 plus 3x, right? Because we can't add unlike terms, can we? So that's kind of an example of when I is acting like a variable, right? We can't add those. What's 2 times 3x? 6x. Can we say 2 times 3i? Yes, we can. Okay? So we can't add or subtract real and imaginary, but we can multiply them. Okay? Now, back to the show. So what do we do here? Oh, distribute. Okay, let's distribute. So 2 times 3, 6. 2 times negative 5i. Negative 10i. Okay, 3i times 3. So plus 9i. And then 3i times negative 5i. Negative 15i. Okay, so what do you see? Oh, wait, that's not right? Oh, I squared. Okay, awesome. What do you see? Simplify what? Okay, so this is actually negative 1, right? So this number right here becomes what? Positive 15. So what's 6 and 15? 21. Anything else we can do? Oh, or add our imaginary parts. Okay, what's negative 10i plus 9i? Minus I. Do we need to put minus 1i? Can I if I want? Yes. That's the same as variables, right? Okay. Now, what if I realized this first, like I recognized this first, and simplified this first? Could I have written negative I plus 21? If I did, all of our professional mathematician friends would laugh at us because we don't do that. We write complex numbers in the form a plus bi, real, then imaginary. Okay? So we don't want our professional mathematics friends laughing at us. We also don't want the complex number police coming to give us a ticket. Okay? I am a deputy. I can give you a ticket for that. So just be careful. Got it? Okay. How do we feel about adding, subtracting, and multiplying? Okay? If we're going to add and subtract and multiply, what else are we going to do? Divide. Before we can divide, though, let's talk about complex conjugates. This is where people forget step 1. Again. Why? It sounds hard, doesn't it? Okay? Complex conjugates. A plus bi and A minus bi are complex conjugates of each other. Their sum is a real number. I'd like to prove that to you. Their sum is a real number. What does sum mean? Add them. So if I say A plus bi plus A minus bi, let's add them together. What do we get? Real parts give me 2a, and imaginary parts give me, oh, their sum is a real number. Is that a real number? Yes, it is. And their product is a real number. I would like to prove this to you. A plus bi times A minus bi. Distribute. What's A times A? A squared. What's A times negative bi? A, bi. Good. What is bi times A? A, bi. And what's bi times negative bi? So negative b squared I squared, right? Right? B times b is b squared? And then I times I is I squared? Okay. What happens here? That's 0. And what happens here? Negative 1. So what I end up with is a squared plus b squared, right? Is that a real number? It's plus, right? It's a real and a real. That's plus, right? Now, can we take another quick commercial break? What is this also? The sum of squares. Remember when we were doing factoring, we said the sum of squares? What did we write when we had the sum of squares? Prime, because at the time we didn't know how to factor it. We can factor it now. A at the beginning, opposite signs in the middle, bi. So if this was a 9, this would be 3i and negative 3i. Dun, dun, dun. We'll talk about that later. Don't worry about it. I just wanted to point it out since we were here. Okay? Back to the show. You ready? So we just proved that the sum is a real number and the product is a real number. I don't ever want you to just assume something's true just because I tell you. You should have proof. That's fair. Okay? So examples. I want you to be able to tell me what the complex conjugate of all these things are. Is this when we panic? Oh, no, it's not? Okay. Look at it real quick. What happens to the real part from one to the other? It's exactly the same, isn't it? What happens to the imaginary part from one to the other? They're opposites, aren't they? So if I tell you 8 plus 5i, what is the complex conjugate? 8 minus 5i. Done. If I tell you 4 minus 3i, what is the complex conjugate? 4 plus 3i. Done. If I try to trick you and say 6, what's the complex conjugate? 6. Real parts stay the same, don't they? And if I say 4i, which for the record is my favorite imaginary number, it was my nickname growing up, what is the complex conjugate of that? Negative 4i. And by favorite, I mean I cry every time I have to write it. We good? Okay. Why do we need complex conjugates? Well, we need them so we can divide. Okay? Because when we're dividing complex conjugates, we can't have i's in the denominator. Remember how we had to deal with radicals because we can't have radicals in the denominator? Same thing here. We can't have i's in the denominator. The way we get the i's out of the denominator is to multiply by 1. And I know that seems weird, okay? But the value of 1 is our choice. We choose what we multiply by. It just has to equal 1. Because multiplying by 1 doesn't change the value of whatever number I'm multiplying by, right? Our value of 1 that we're going to choose is the conjugate of the denominator over the conjugate of, how do I get 1? Yep, I divide it by itself. So here's what I mean. Is this fraction allowed? 7 over 3i. It's not allowed because there's an I in the denominator. What is the conjugate of the denominator? Negative 3i, right? So I'm going to multiply this by negative 3i over negative 3i. How do I multiply fractions? Straight across, right? So what is 7 times negative 3i? Negative 21i. And what is 3i times negative 3i? 9i squared, right? I times I is I squared, right? But what do I know about this? Negative 1. So what's my denominator actually? Negative 21i over 9. So why is that not the answer? It is not simplified. What can I do to simplify it? Okay, so if I divide by 3 from the numerator and the denominator, what do I end up with? Negative 7i over 3. Now, because some of you are observant, somebody earlier said, so I just flip this over and make it negative? No, that would be nice. But first of all, this is a 3i and this is a 7i, so we didn't really flip it over. And no, I'm not just moving the I to the top. Okay? It just happened to work that way in this problem. Let's do this problem, this second one, and you'll see that that doesn't always work. Is that fair? Okay. Why do I have to do anything to this problem? Yep, there's an I in the denominator. Okay? So when there's an I in the denominator, figure out the conjugate of the denominator. What is it? So 2 plus I over 2 plus I. That's what I'm going to multiply by, right? What is 6 times 2? Oh my gosh, it's so good that we just did multiplying complex numbers because now we know what to do, right? What is 6 times 2? 12. What is 6 times I? 6i. What is 4i times 4? And let me say the words right. What is 4i times 2? 8i. And what is 4i times I? 4i squared, right? Now the denominator. What's 2 times 2? 4. What's 2 times I? 2i. What's negative I times 2? And then what's negative I times I? Negative I squared, okay? What do you notice? Let's start with the numerator, please. What do you notice in the numerator? I squared. What is that equal to? Negative 1. So this number right here is actually what? Negative 4. So I have 12 minus 4. 8. What else do you notice in the numerator? Absolutely. 6i and 8i. 14i. Is that all we can do in the numerator? Okay, what about the denominator? What do you notice? I squared, what does I squared equal? Negative 1. So this number right here is actually positive 1. So what's 4 and 1? 5. And then what happens right here? That goes to 0, doesn't it? Done. So our foldable is almost done. What's the last thing we need to do? Yep, turn it over, write your name. Again, please don't write my name, write your name. Okay? Any questions about this? Now, let me show you something. Do you remember this? Let me zoom out. From the beginning of the year, we made this, right? So we've just added to this. Because it used to be that, right? Real numbers is here, but now we've added a whole nother section. Isn't that cool? Here's what else I want you to know. Why would I teach you something really cool like complex numbers? So you know how to do them, right? Because you're going to need to know how to do them. But now normally I only get this question when stuff is really hard. Because if it's easy, you don't care what you're going to do with it, right? When it's hard is when you want to know. Here's the question I get. When are we ever going to have to use this? Right? You don't ever ask me that when it's easy. You ask me that when it's hard. Okay? But here's what I would like to tell you. In the 17th century, I wasn't alive then, so I wasn't there. But there was a man named, I also don't know if I'm saying this right, because again, I wasn't there. Girolamo Cardano. Okay? He's the one who invented imaginary numbers. Because he was trying to solve cubics. Okay? But here's also what I know about complex numbers. Square rooting negative numbers. Here's what I know. There's a thing called the Fourier transform. The Fourier transform, among other things, it's a formula that helps eliminate background noise from recordings. Is that something that you guys might be involved in or interested in? You might do that, right? You might work in a studio working with recordings. AC circuits. Have you ever heard of that? Electricity, right? In electricity, you express the magnitude and phase of impedance in AC circuits using complex numbers. Have you ever heard of quantum mechanics? Quantum mechanics is the study of motions and interactions between subatomic particles. You can't study that without knowing complex numbers and using complex numbers. Okay? Now, are all of those subjects that you, your specific self, are going to study when you grow up? No, but can you see how that's used? Okay? Any questions? Oh, I have one more thing. I'm sorry. One more thing. Besides all of that I just told you, without understanding imaginary numbers, you wouldn't understand this comic. Here's another math problem I can't figure out. What's 9 plus 4? Oh, that's a tricky one. You have to use calculus and imaginary numbers for this. Imaginary numbers, you know, like 11, 30, 12, and all those. It's a little confusing at first. How did you learn all this? You've never even gone to school. Instincts. Tigers are born with it. Or this one. You're irrational. Get real. See, because it's the square root of negative 1. Or this one. It's all fun and games until someone loses an eye. Or this one. Or my personal favorite,